Okay, question 22. So it says a ball is released and it falls vertically down towards the ground, and we've been given a distance time graph for it. So air resistance we can ignore. It tells us what the graph says, that it hits the ground at half a second here, and then it's momentarily on the ground, I guess, while the ball's compressing and then rebounding back again for 1.8 milliseconds. That's not really shown on the scale of the graph. And then we're given the mass that we're going to be needing at some point for a calculation, I would imagine. And then it says explain the variation from 0.2 to 0.7 seconds of the velocity, and also not only describe it but explain it as well. So just make sure that we're clear on which parts of the graph we're talking about. It's only those bits. And so we remember when we've got extended writing and 4 marks, just to plan it out a little bit in our head first. So this is a distance time graph. We've been asked to talk about the velocity, so we need to focus on the gradient. And we can see that the gradient of this line gets steeper and steeper and steeper and steeper as it comes towards the ground, and that's because it's accelerating. And then as it bounces off the ground again, it gets shallower and shallower and shallower and shallower, and that's because it's decelerating. So already we can say 3 things. We can say that the gradient tells us the velocity, and that the gradient is getting steeper, so that's accelerating, and then after the bounce the gradient's getting shallower, so that's decelerating. So you can start putting those ideas into words. So gradient of the graph indicates the velocity, 0.2 seconds through to 0.7 seconds it's accelerating as getting steeper. 0.5. 0.5 seconds through to 0.7 seconds it's decelerating as it's getting shallower. So we're describing and we're explaining. The description bit's the acceleration, the explanation bit's getting the reference to the gradient. So we've said 3 things, so we're probably on our way to 3 of the 4 marks. We just need a 4th thing to say. So what we can say is that the gradient changes sign at 0.5 seconds, and that means that the direction has changed. Changes from downwards to upwards. Okay, so that'll get you your 4 marks. You could also, if you wanted to, make reference to the fact that there will be a loss of energy here. So you can see that this graph is quite steep here, and it's not as steep here. So had you missed out one of these points, you could also have talked about the fact that when the ball rebounds from the ground, it's not travelling as quickly as when it hit the ground. A little bit of exam technique to pay attention to. The focus of this question's all on the graph. So they're giving you a graph, make reference graph. Don't do any calculations. So you need to carefully interpret this word explain. Some of the scripts that you gave me that I marked, you were trying to explain literally by appealing to the mechanics of what's going on about collisions and changes of momentum and things like that. When the context of the question is all about the graph and they use the word explain, they want you to explain your description in terms of how you arrived at your conclusion. So if you're claiming that something's accelerating, they want you to explain the word accelerating. Why have you used that? Why do you know it's accelerating? They're not asking you to explain actually physically why is the ball accelerating. They don't want you to say things like the force due to gravity is pulling the ball down and F equals ma means that there'll be some acceleration. The word explain is referring to can you use the graph to explain your conclusion. Okay, this side of the piece of paper is all about calculations though. So use an equation of motion to show that the speed is what it is just before it hits the ground. You've been given 2 marks, so 1 mark is going to be for selecting the equation of motion, and the other mark will be for demonstrating using it, and you won't get any marks for coming up with an answer of 4.9. So what numbers have we got? Well, we know that it took 0.5 seconds to hit the ground, and we know that it started off at 1.2, each one of those little boxes is 0.04, so what, 1.23? So we kind of got S as 1.23 meters, T as 0.5 seconds, A is from gravity, and we'd quite like to know V. I suppose if you want, you've got U as well, starts off as 0. So you've got the full suite apart from V, which means you can use any equation of motion, so you might as well go with the one that gets you the answer quickest, which is V equals U plus AT, U is 0, and so we've just got 9.81 times 0.5, which gives us our 4.9. So in terms of what mark you're getting here, you'll get 1 mark for kind of selecting the equation of motion and setting up use for it, and 1 mark for actually using it. So try and get all of that into the box if you can. Okay, so this is the speed it hits the ground at, but now we're being asked to work out the rebound speed, which is the speed it comes off the ground at. We've already noted that that's a little bit slower, so we just need to stick a gradient on this. So if we do something like, something like that. Okay, so each one of these little squares is 0.04, so that's 0.88, and that's 0.25. So you want to be doodling something like that on your paper, and then just over here you just need to do the calculation to get the speed. And that gives us 3.52 meters per second, which is in line with the 3.5 that we've been asked to show. So again, for your 3 marks here, you'll get 1 mark for drawing on a tangent, 1 mark for using the tangent to come up with a value, and then the 3rd mark is actually for your tangent being an appropriate one. So if you'd have made it very, very steep or very, very shallow, you'd have got values that was quite a long way from 3.52, and that wouldn't have been acceptable for the 3rd mark. It's kind of an accuracy mark. So the exam mark scheme states that they will accept anything in that range. Okay, calculate the average resultant force acting on the ball during the collision. So whenever you see average resultant force, you need to be thinking that we're going to be smearing something out that's maybe quite complicated over a period of time. And you can see here that they have told us that the collision lasts for 1.8 milliseconds, and then also note that they've given us a mass that we haven't used yet, and so we should find ourselves being drawn towards the formula, if you remember, that the average force multiplied for the time that it acts for is equal to a change in momentum. And it really is this word average that's drawing us towards this formula, hinted by the fact that they've given us a mass that we haven't used yet, and we've been using these velocities so we can work out a change in momentum now. So we've been asked for the average force, so F equals, so change in momentum is mass times velocity. The mass isn't changing, so we can pull that out, so that's 56 grams, don't forget the 10 to the minus 3, multiplied by the change in velocity, so it was 4.9. Take away its new velocity, which is 3.5, but remember the 4.9 is downwards but the 3.5 is upwards, so one of them needs to have a minus sign, and then we need to divide that by the time, which was 1.8 milliseconds, and then by writing it out like this you can see that you make your life easy because you can now cancel out the powers of 10, and then when you put that in your calculator hopefully we'll get a reasonable number. Okay, so we're coming in at 261 newtons. Now that actually does seem like quite a large force, but I guess you can imagine what if the ball wasn't bouncing off the ground but was bouncing off you? If someone threw the ball at your chest and it bounced off your chest, you'd notice that it hit you. It wouldn't be a gentle force. It would sting. If you've ever been hit by a tennis ball, I guess you'll know that. So it's not an unreasonable answer, and it shouldn't overly worry you that it's 200 and something.